Welcome to Chapter 5. This chapter involves learning about more z-scores and formulas using z-scores. And then we're also going to talk about t-scores. So let's dive in. So we're going to warm up by talking a little bit more about the normal curve. Specifically today we're going to have a little history lesson. This is Carl Gauss, and he is the father of the normal curve, or as he liked to call it, the Gaussian curve. So he's a German mathematician, and he's often referred to as the greatest mathematician of all time. Some people say that he was just like born with perfect pitch in terms of math, so he's considered by many as a mathematical prodigy. Was considered a mathematical prodigy by many at a very young age. And then people say he did math before he could talk. And again, he is the developer of the normal curve, or sometimes it's called the bell curve, or the Gaussian curve, named after himself. So he was alive from 1775 to 1855. And I'll post some information about him in the bonus content if you're interested in learning more. So for the upcoming quiz, be sure that you are able to answer this question on the knowledge check here. What does a z-score tell you about a raw score? And when you see that question on the quiz, the answer is going to be that a z-score tells us the number of standard deviation units a raw score is away from the mean. Okay, so the work that we're going to do with z-scores is basically to learn a bunch of formulas that contain z-scores, and so that we're able to use different bits of data to solve for different values that we want to find, all involving z-scores. So what I recommend that students do is, because this is a lot of formulas and there's just going to be more formulas over the course of the semester, as you can imagine, is I recommend that students just have like a cheat sheet with all the formulas written on it, and they just kind of add to that cheat sheet as the semester goes on, and then have it handy whenever you're taking quizzes or the final exam. So at any rate, what we're going to learn to do in the upcoming Z-Score Revisited worksheet, which you are going to need to grab off of Canvas in this same module, is we're going to go through all of these different formulas here. So I'll just kind of go over them quickly now, but then you'll follow along with the tutorial and learn how to calculate them in a more hands-on way. So the first bullet point says if you want to find a raw score from a z-score, you're going to use that formula there. Raw score equals your z-score multiplied by your standard deviation plus your mean. And you can see an example of calculating through that formula right beneath its bullet point. I would just like to say that when I was in graduate school, I had the same statistics instructor for every statistics class that I had. And she would always give back our quizzes in z-scores rather than having our raw score on them. And so in order to figure out if you passed or failed, the first thing you'd have to do is look at your z-score and see if it's positive or negative. And then from there, you'd have to do this calculation that I'm going to teach you now to get your exact raw score. It was torture. So I won't be giving you your quizzes back in z-scores and making you calculate your raw scores, but it certainly emblazoned in my brain how to convert a z-score to a raw score for sure because of that grad school experience. Okay, so the next one is to find a raw score from a percentile. So the raw score formula is the same as above. However, you'll note that in the raw score formula, it has a z-score. And so sometimes you'll be given word problems where you're not given a z-score, but instead you're given a percentile. And so you'll have to use table B to find the associated z-score with that percentile. And then from there, you're able to calculate the raw score because now you have that missing z-score. So you can look at the example calculation beneath if you need an example, but again, we're going to be doing it on the tutorial coming up in just a second. And then the next one is how to find a standard deviation from a z-score. So if you're given a z-score, you would also need to be given the raw score and the mean in that same data set, which you will be, and then you'll calculate through and find that standard deviation. And then if you want to find a mean from a raw score, the mean formula is raw score minus z-score times standard deviation. So let's go ahead and practice all this on the Z-Scores Revisited worksheet. Welcome to the Z-Scores Revisited worksheet. And so the first problem that we're going to do is this top one that says from z-score to raw score. And so the formula for this here is x equals your z-score multiplied by your standard deviation plus your mean. So in other words, we are solving for x. So we're looking to find a raw score, and we're being given a z-score to do so, as well as a standard deviation and a mean. So to solve for this, we need to pull out our puzzle pieces. So to solve for x, the puzzle pieces we're gonna need are the mean. So I'm gonna write that off to the side here so I have that info. And the standard deviation is going to be 15. And then I have a z-score here, and then for this other problem, I have a different z-score. So I'm gonna use this mean and this standard deviation to get the raw scores for these two z-scores. So in order to do that, I need to solve through this formula. So I'm going to start by writing down my z-score of 0.56, and I'm going to multiply that by the standard deviation of 15. And then I am going to add that to the mean of 100. And so to solve through this problem, I'm going to start by multiplying 0.56 and 15. And when I do that, I'm going to get 8.4. So then I'm going to take 8.4, I'm going to put a 0 there for the placeholder, plus 100. You don't have to put the 0 there, I just like it. Okay, and then when we calculate through that, we're gonna get 108.40 as our final answer. So I will write that on the line there, 108.40. Okay, now I'm gonna do that same formula again for this z-score. I would suggest that you try to do it by yourself now, so maybe pause the video and solve it on your own, and then you can play back this next portion where I'll solve it for you so you can check your work. Okay, so the z-score is negative 0.10, and that's going to be multiplied by the standard deviation, which we have as 15. And I'm just putting, these in parentheses for clarity. And then I am going to add those values to the mean, and the mean we pulled out and set to the side as 100. So again, we're going to do the parentheses first, and we get negative 1.5, and we're going to add that to 100, which actually works out to be a little bit of subtraction. So you end up with 98.50. So the answer for the second raw score is 98.50. So a z-score of negative 0.10 converts to a raw score of 98.50 in this data set, and a z-score of 0.56 converts to a raw score of 108.40 in this data set. Okay, the next thing that we are going to do is take percentiles and convert them into z-scores. And in order to do that, we are going to need table B. Okay, so on table B, we are able to identify a percentile and then find the equivalent z-score. And so if we look at this worksheet, the 95th percentile is equal to what z-score is the question. So I'm going to come over here to table B and look at the 95th percentile, and I'm going to find that that is equal to a z-score of 1.65. I'm just going to write 1.65 here. And then I'm going to look at the 10th percentile on my table B, and that is equivalent to a z-score of negative 1.28. So I'm going to write that on my answer line here. Okay, and then I encourage you to, again, pause the video, look up the 55th and 75th percentile on your own, and then come back to the video and check your work. So here are the answers for the 55th percentile and the 75th. The 55th looks like it is equivalent to a z-score of 0.13. So I'm going to write that here. And the 75th looks like it's equivalent to a z-score of 0.67. So I will write that here. Okay, so that's how I get z-scores from percentiles. The next thing I'm going to do is move from a percentile to a z-score to a raw score. So if you're given a percentile and asked to identify the equivalent raw score, how would you go about doing that? So what you would need to do is first think to yourself, what am I solving for? Well, the final outcome, what's on the answer line is an X. So I'm solving for X, or I need to get the raw score. So let me go to my notes and find my raw score formula, which is X equals a Z times the standard deviation plus the mean. And then I can start figuring out what puzzle pieces I have and what puzzle pieces I need. So in this formula where I'm solving for X, I'm going to need a Z-score. Don't see any mention of a Z-score here, so that's we're going to leave that blank for now. And then the next thing I need is standard deviation, and here it says standard deviation is 90. So let me write that off to the side. And then I'm going to go ahead and put it in my formula. And then the formula says to add the mean to it. So I'm going to add a mean of 1500 to that equation. So what I'm missing is a z-score. And so I don't have a z-score anywhere here in the word problem, but what I do have is the 45th percentile. So I just need to make a mental note that I can get z-scores from percentiles on table B. So in order to get the z-score, I am going to look it up in table B. Table B will get you that Z. Table B for Z. I love a good mnemonic. Okay, so if I go to table B and I look up the 45th percentile, I get a z-score of negative 0.13. So I'm going to write that in my formula here. It's my missing puzzle piece, and now I'm able to calculate through. So if I take a negative 0.13 and multiply it by 90, I'm going to get negative 11.7. And then I'm going to need to add that to 1500, which is the mean. That's actually going to result in some subtraction. And so my final answer is going to be 1488.3. So the raw score for this data set that is at the 45th percentile and a z-score of negative 0.13, the raw score for that location on the curve is 1488.30. Okay, and then go ahead and try the 79th percentile on your own and come back to the video and check. I'm going to go through the solving of the equation now. So the first thing, again, that we want to do is identify what am I solving for. I'm solving for X. So let me find my raw score formula, my formula for X. And then let me write it out and start finding the puzzle pieces out of the word problem. So it says I need a z-score. I don't see a mention of a z-score, but I do have the 79th percentile. So I know I can go to table B for a z. So, the 79th percentile is equal to a z-score of 0.81. So I'm going to write 0.81 here in my formula. Okay, so now that I have 0.81 in there, I'm going to multiply that by the standard deviation. And the standard deviation here is 90. And then I'm going to add the mean of 1500. And then when I calculate through that, I would start by doing this multiplication here. And when I multiply 0.81 by 90, I get 72.9. And then I'm going to add that to 1500, and that is going to result in a raw score equal to 1572.90. Oh, I forgot to block this one. Okay, so I'm going to put that my answer key or my answer line. 1572.90. Okay. All right, and then if we wanted to move from a z-score to a standard deviation, how could we get a standard deviation if we know a z-score? In other words, how can we use information from a data set that contains the mean, a raw score, and a z-score or equivalent percentile to get a standard deviation? So if the mean is 115, find the standard deviation for the following raw scores. So this is a raw score of 120, and this is a raw score of 85. I'm going to pull out what I have, the puzzle pieces that I have. I have the mean of 115, and then I do have my raw score here. So this is the formula that I'm going to be using to solve through this. So I need a raw score, found that. I need a mean, found that. And I need a percentile because I don't have a z. But I know I can use a percentile to get a z. I just go to table B for a z. So if I look at the 60th percentile on table B, I get a z-score of 0.25. So the 60th percentile is equal to a z-score of 0.25. So I have my raw score, my z-score, and my mean. The formula requires the raw score, the z-score, and the mean. So I'm good to go. So I can just start plugging these values in. So the raw score was 120. The mean was 115. And then the z-score we looked up on table B was 0.25. So if I calculate through this, I'm going to get 120 minus 115 is 5. I'm going to pull that denominator over, do the division there, and that is going to render me a standard deviation of 20. So I put 20 on the line. Okay, go ahead and pause the video and try getting the standard deviation from a raw score of 85 for this data set. And then come back. And now that you're back, go ahead and follow me as I solve through this. So first I need the x is 85 minus the mean is 115 over the z-score. We don't have a z-score, we have a percentile. But we certainly know that we could go to table B for a z. So the 7th percentile says negative 1.48 is the equivalent z for the 7th percentile on this data. So then I am just going to divide that numerator by my z of negative 1.48. And then calculate through. So 85 minus 115 is going to be negative 30. Carry that denominator over. Do a little division. And I'm going to end up with 20.27. And put that on my answer line. Okay. All right, so now we're going to go from the z-score to the mean. So we are solving for the mean. So I'm going to look up on my notes what my formula for my mean is, and it looks like it's the raw score minus the z-score multiplied by the standard deviation. So we have a standard deviation of 10, we have a raw score of 50, and we have the 35th percentile. So I know the standard deviation is 10, I know the raw score is 50, but I don't have that z. However, I do know that I can go to table B for a z. Sorry, I shouldn't have sung that. Okay, so the 35th percentile is negative 0.39. So the z-score at the 35th percentile is negative 0.39. Okay, now I have all the puzzle pieces I need to solve through this. So I'm going to just start plugging them in. The raw score is 50 minus the z-score we found on table B of negative 0.39. And we're going to multiply that. I'm going to put this in parentheses too. And we're going to multiply that by the standard deviation that's given in the word problem of 10. So I'm going to do parentheses first to solve through this. So 0.39 times 10 is negative 3.9. And then I'm going to subtract the 50 from there. But in a strange twist, a negative and a negative actually make a positive. So 50 minus negative 3.9 is going to give you 53.9. So the mean for that first one is 53.9. Okay, pause the video, do this one on your own, and then come back. Welcome back. Okay, the 85th percentile is equal to a z-score of 1.04. So I can solve for the mean because I have a z-score, I have a raw score, and I have a standard deviation. So I'm going to just plug them in their appropriate position. So the first thing is the raw score of 1600. We're going to subtract that from the z-score we found on table B. And we're going to multiply that by the standard deviation of 100. And so when we multiply 1.04 by 100, we get 104. And we want to pull down that 1600 and subtract. So 1600 minus 104 is going to get you 1496. So the mean for that one is 1496. Okay, so another raw score transformation is called a t-score. And a t-score is a converted z-score, but the mean is always set at 50 and the standard deviation is always set at 10. So it's a standardized curve, and basically it's just another measure of how far a raw score is from the mean. However, it's always a positive number, and that's the thing about t-scores that people like. Sometimes, especially in like education, if you have to explain to parents how well their child is performing using z-scores, it can be challenging, and it can be sometimes upsetting to people if you tell them that their child is getting a negative z-score. And so t-scores just keep everything positive, and in psychology we like that. But also it just makes it a little bit easier to understand because people are kind of put off by negatives sometimes. So you could just put t-scores in your toolbox of an option that you could use. If you ever need to report a negative z-score and don't want to offend somebody, just get in that toolbox, grab that t-score, and transform that negative z. All right, so calculating t-scores, you're going to find a t-score the same way that you solve for a raw score by taking the z-score multiplied by the standard deviation plus the mean. However, here the standard deviation is set at 10 and the mean is set at 50 because this is a standardized distribution so that we can get those positive numbers. And then there's an example of how to move through the formula there. And the next thing that you need to know, and the next formula that you should add to your little formula cheat sheet, is how to get a z-score from a t. So in the above formula, we're getting a t-score from a z. And in this next formula, we are getting a z-score from a t. So we're going to take the t and then minus the standardized mean of 50 and divided by the standardized standard deviation of 10, and that will give us a z-score. If we then wanted to find out a raw score, we would be able to take that z that we just calculated from a t. So in this scenario, we're pretending that we weren't given the z, we were just given a t and then asked to find a raw score from that. So we calculated that z-score so that we could plug it into our raw score formula here. So the first thing we did was take that t-score and convert it to a z-score, and now we're going to plug that z-score into our raw score formula. And that's how we go from a t to a z to a raw score. Again, there's another example just below on your slide here, but I'm going to show you how to work with t-scores on that Z-Scores Revisited worksheet right now. So go ahead and grab that back out. Okay, so now we're going to go from a raw score to a Z-score to a T-score. And so this portion of the worksheet's a little bit congested. So what I like to do is draw a line right here and kind of keep this side separate from this side because they're two different calculations. So I'm going to do this top one, and then you can try that one on your own and come back to the video to see if you did it correctly. So what we need to do is kind of think through how we're going to solve this. So what we are trying to solve for is t. So the first thing I need to do is find my t formula and write that down. So here it is, t equals z times 10 plus 50. So I need to find my z-score. And I have a mean, I have a standard deviation, and then here I have a raw score. But I'm not given a z-score. So I'm going to need to find my z-score formula and write that down. And so the z-score formula is x minus the mean over the standard deviation. The raw score minus the mean over the standard deviation is going to get me my z, which is my missing puzzle piece here. So I'm going to start by finding my z. And so I need to use this formula. I need the x is going to be 400 minus the given mean of 500 over the standard deviation of 95. And this is giving me my z-score that I'm missing from my t-score formula. So when I calculate through this, I am going to get a z-score that is equal to negative 1.05. And so now I'm going to be able to plug that into this formula here. So t is going to equal that z that I just calculated times 10 plus 50. So I just pulled that down from the t formula. And then I'm going to just start solving through. So I'm going to do negative 1.05 times 10, and that's going to get me negative 10.5. And then I'm going to add that to the remaining value of 50. And so when I take negative 10.5 plus 50, it results in a subtraction that gets me 39.5, which is my final answer for this one here, 39.5. Okay, so I'm gonna do the same thing for this one down here, the same process of getting my z first and then solving through the t formula. So go ahead and pause and then come back. Okay, so the first thing that we're gonna need to get our t is our t formula. It says we need a z. We're not given a z, so we're going to use our z formula to calculate it ourselves. So in this particular problem, the raw score is 550. So we're going to take the raw score of 550 minus the mean of 500 divided by the standard deviation of 95. And that is going to give us a z-score that's equal to 0.53. So then we're going to start solving through our t formula. We're going to use that 0.53, and then we're going to pull down that standardized standard deviation of 10 and that standardized mean of 50. And then we're going to go ahead and calculate through that. So 0.53 times 10 is going to be 5.3 plus 50 is going to equal 55.3. So that's our answer for this t-score is 55.30. All right, and then we have a separate set of problems over here where we're going to kind of flip it and go from a t to a z to an x. Where here we went from an x to a t, we're going from a t to an x. So we want to solve for x, and we're going to need our raw score formula in order to be able to do that. So our raw score formula is x equals the z-score times the standard deviation plus the mean. So let's see what of those values that we need, which ones do we have? So we have the mean of 35, we have the standard deviation of 4.5, and then we just need the z, but we don't have the z. We do, however, have a t, so we can use that as a clue to get us the z. So if I need a z-score from a t-score, I'm going to use this formula here. This is the formula that we used here. But this formula to calculate a z requires a t, and that's what we have here, not an x. So we're going to calculate our z-score by taking the t of 43 minus the standardized mean of 50, that's always part of the formula, over the standardized standard deviation of 10. And that is going to give us a z-score equal to negative 0.7. And so now we would be able to go ahead and solve for x using our raw score formula because we've obtained a z from a t. So for the raw score, we're going to take that z that we just calculated of negative 0.70, and we're going to multiply it by the standard deviation, which is 4.5 for this data set. And then we're going to add it to the mean, and in this data set, the mean is 35. So then if I take negative 70 and I multiply it by 4.5, I'm going to get a value of negative 3.15. I'm going to add that to 35, and my final answer is going to be 31.85. Let me put that on my raw score line right there. Okay, so go ahead and do that next one on your own and then come back and I'll solve through it for you. So again, for this here, getting a raw score from a t-score of 78 is going to require a z-score because our raw score formula is z times the standard deviation plus the mean. I don't have a raw score formula that has a t in it, so I'm going to have to convert this t to a z-score before I can solve for this. So my z-score formula using a t is right here, and it is z equals the t. In this case, the t is 78 minus 50 over 10. So when I calculate through that, I get a z-score that's equal to 2.8. And now I'm able to solve through my raw score formula. So the z of 2.8 times the standard deviation of 4.5, I'm still using this data set here, plus the mean of 35. It's going to equal, so I'm going to do 2.8 times 4.5, and that's going to give me 12.6 plus 35 equals 47.60. So a t-score of 78 is equivalent to 47.60 for this data set. And that is the Z-Scores Revisited worksheet. Okay, so let's talk about other normal curve transformations. There are normal curve equivalents and stenines and grade equivalent scores. And so before we talk about those, let's just review the normal curve transformations we already know. So the very first transformation we did of the normal curve was we had a normal curve and we transformed it into a standard normal curve. On the normal curve, we have raw scores on the x-axis, and when we transformed that into the standard normal curve, we put z-scores, also known as standard deviation units, on that x-axis. And then from there, we took the normal curve and we transformed it into a T-score curve or distribution so that we could present Z-scores in a different light. And so those are the normal curve transformations that we've done so far. And here's just a few other for you to know. So there's something called normal curve equivalence, and this is another popular standardized score like the Z-score or the T-score. And you calculate it by setting the mean at 50, and where in the standard deviation in our T-score curve is 10, the standard deviation here is going to be 21. And also you're going to expect a larger range than you would with T-scores because of that larger standard deviation. Okay, another normal curve transformation are called stenines, and this is a standardized score used mainly in educational psychology. So where the Z-score distribution divides the curve into 6 chunks or 6 units, when we have stenines, it divides the normal curve into 9 units. And then there are also normal curve transformations called grade equivalent scores. And these are standardized scores that are, again, popular in the field of education. And they're based on the average score found for students in a particular grade at both the same age and time of year. So, for example, a grade equivalent score of 6.9 would indicate a score that a 6th grader in the 9th month of the school year receives on average. So if your kid is in 3rd grade and gets a GE score equal to 6.9, that means they're performing like your average 6th grader in the 9th month of school would perform. And then I have another example here. A 3rd grader in the 1st month of school could take a test and get a GE of 4.5, and that would mean that they tested at the level of a 4th grader in the 5th month. So those are grade equivalent scores, and that's it for Chapter 5. I will talk to you on the next one. Have a great day.